Hello again. We are still in chapter 1, part 1, trying to understand the concept of variables and the roles of variables in programming. As agreed, our modus operandi will be first to look at worked examples where we shall analyze codes, then compile such programs on the computer and see how the computer reacts, and then visualize these particular worked examples using physical models. And after visualizing the same worked example using physical models, we shall visualize the same code using RAM diagrams. So after doing visualization of the same program using physical models, let us now go and see how to visualize the same program using the so-called RAM diagrams. First of all, let us first appreciate that this is the program that we have been dealing with. This is the worked example which constitutes our discussion, whereby the first part is made of libraries, include, using namespace, whatever. Then at line number 4 we have int main, and the program is starting from line number 5 ending at line number 14. So from this line and this line and this line we have what we call variable declaration. At this line and this line we have data feeding, and on line 11 there is where we have the process. And now let us go and see how this particular program can be interpreted using the so-called RAM diagrams. To use RAM diagrams, we have first of all to bring about the entire program at the fora. So let us start with the libraries, that is include, let's say IO stream. Then there follows other libraries, and then we have int main, that is the header of our main function. After int main we have this opening curly bracket, and then we have the declaration of variables, that is int x, y, and z. This is declaration. So now after declaration of variables, we have data inputting x equals to 5, y equals to 7, and after data feeding we have processing where z equals to x plus y, and after operation we have outputting, that is cout z, what is in z, then we have return 0, and here we finish with closing curly bracket. Now after that, let us now try to understand each statement accepting the libraries by using RAM diagrams. So the first issue that we have to understand is that the computer memory is like a bank of empty spaces which are waiting to be booked and fed with data. So this is RAM of the computer. This is computer RAM before any statement is executed. Now, when the computer comes to int x, int y, int z, this particular memory will change and the RAM status will be as follows, that is RAM. So the same RAM will have one of it labeled as x due to this statement, another one will be labeled as y due to this int y, and after int z, another will be labeled z. So here we have this one reserved, this is reserved, and this is reserved, while the rest remain empty. They are not reserved. But even these ones which are reserved, they don't have data yet. So what follows now is data inputting. X equals 5. So, and y equals 7. Now, when x equals 5 is encountered, what happens in the memory is that the room x will receive content 5, y will remain reserved, and z will remain reserved, and the rest will remain empty. But then, when y equals 7 is encountered, then this particular RAM will change status and 5 will be in X, then 7 will be now in Y, Z will still be reserved, and the rest is empty. So that is as far as this line and this line are concerned. So when we get to the next line, that z equals x plus y, this particular memory will change and it will become as follows. X will be with 5, y will be with 7, but now z will receive 12, which is the addition of 5 and 7. So this is going to be the result, while the rest of memory will remain empty. When we come to the line that C out z, we are now asking ourselves, what is in z? So the computer will come and look into variable z, and the content of that variable, which is 12, will be reflected on the screen. So this is just another way of analyzing each line of code in order to understand how the computer interprets a program and how it solves these problems. So this is the second way of visualizing a program using what we call RAM diagrams. So all these are the RAM of the computer, which keeps changing according to, this is the screen, according to the way the program is executed. So far, that could be the best interpretation and the best visualization of this particular program. And thank you for now. Bye-bye.